lesson for today. It's all about vectors in space. Okay, so a vector in space is specified in a three-dimensional coordinate system with x, y, and z axes mutually perpendicular to each other. The components of a vector v along these axes are usually written as v of x, v of y, and v of z. As you can see on the plane, any vector is the vector sum of its components. So the vector can be expressed in a more compact form as the sum of its component, using unit vector. A unit vector is a dimensionless vector with a magnitude of 1. 3 unit vectors should be defined as I hat, j hat, and k hat. Let I hat be a unit vector along the positive axis, so that's the I. J be the unit vector along the y-axis. So along the y-axis is this. And the z is the positive z-axis. K is the positive z-axis. Okay? So that's in terms of the unit vectors, we have this formula. So v equals v of x I hat plus the vector y j hat plus the vector z k hat. So where vx, vy are the magnitudes of the vector along the x and y axis respectively. So knowing these components, the magnitude of a given vector is computed using this formula. Okay, so we will just get the magnitudes of the vector. Okay, this is actually the diagonal of a prism. It's a formula of the diagonal of the prism. The diagonal of a prism. So let us start given with this example. Vector A has the following coordinates in 3 dimensions: 2.5, 3.6, 4.1, 4.5 in meters. Express a vector in A in terms of unit vector. So we will express it in unit vector and find the magnitude. So when expressing this given 3-dimensional space in meters, we just put I, j, and k. Okay, that is a unit vector. Then after that, we will get the square root of the sum of the square of each. 2.5 plus 3.6 plus 4.5. So what's the value? Try to get the value in the calculator.
6.3.
Okay, meters. Okay. When it is unit meters, unit vectors, you put the I, j, and k. Okay. So let's try this example 2.15. X, Y, Z components of the vectors 2.9, 6.6, and negative 4.6 respectively. Express f in terms of the unit vectors. So f is equal to 2.9 I hat plus 6.6 j hat minus 4.7 k hat. And that's it. And we have the value of the what? Magnitude. So let's try to get the magnitude of f. So f is equal to, use your calculators, 2.9 squared plus 6.6 squared negative 4.7 squared. Okay, so what's the value?
8.6.
8.6?
Yes, sir.
Okay. Newtons. All right. I'm here. You got the same answer also. Okay. Simple, right? Now, operations using unit vectors. When vectors are expressed in terms of unit vectors, it is easier to perform vector addition, vector subtraction, vector multiplication, compared to the methods mentioned in the previous sections. Operations using unit vectors obey algebraic rules, which I, j, k are treated as variables. The dot product as well as the cross product of two vectors follow the distributive law. However, we need to evaluate the dot products as well as the products of any two unit vectors. Okay? So let us try this value. So these are constant, okay? You have to refer all the time later because you are going, when we are going to solve, we will be using this. Okay. When we use the dot product, the dot is different from multiplication product. The dot product is II, JJ, KK is equal to 1. Okay. Later you will see this. IJ, IKJ, KJ, IKI, KJ is equal to 0. Okay. So when it is a cross product, IIJJKK, it is 0. IJ is equal to negative K is equal to K. IJ is different from JI. It's reversed. JK is equal to I. And KJ is equal to negative I. And then KI is equal to J. So when will we use this? When will we use this? Okay, let us see how to use those. So don't forget this, okay? We will go back to this after. So I need to use this.
Sir, it's like proving identities.
No, it's getting values and operations. It is only simple. You will see this. Given the vectors A equals negative I, negative 8I minus 4J minus 6K and B. These are the values. What is A plus B? So when you get the A plus B, you just only add. So negative 8I plus 2I, you will get negative 6I. Negative 4J plus 3J is negative IJ. Negative 6K plus negative 7K is negative 30. It's like polynomials, right? Simple. Next, A minus B, same thing. We will subtract. Negative 8I minus 2I will give you negative 10I. Negative 4J plus 3J is negative 7J because that's minus. Negative 6K minus negative 7K is positive K. Okay. Now, letter C, negative 4A. You will just multiply all the A to negative 4. So negative 4 times negative 8 is 32A. Where is it? Yeah, I. Negative 4 times negative 4J is positive 16J. Negative 4 times negative 6 is positive 24K. So far, this is easy, right? Operations on polynomials only. Okay, let's go to the dot product. The dot product, we are going to use the values here. Okay. I, J, K is always 1. These are all zeros. Okay, so easy to remember, right? J, K is 1. When there is a combination of the two letters, it is always 0. Okay, so let us see. What do you mean by a dot? Look, T is dot product, E is cross product. Okay, let us see. A dot B. A dot B. So you'll multiply negative 8i by, so let's see here. Letter C. It's like this. Negative 8i, you will multiply to 2i plus 3j minus 7k. Also, minus 4j, you will also multiply to this 2i plus 3j minus 7k. What's that? Minus 6k. You will also multiply to this inside, okay? So 2i plus 3j minus 7k. So we'll distribute 1, 2, 3. So negative 8i minus times 2i is negative 16i plus or minus 24i times j minus 7 or plus 56ik minus 8ji here minus
Negative
12jj plus 28jk minus 12 ki or ik, same. Then where are we?
minus 18.
18 kj. And lastly, 42. 42 kk. Okay, all of the double variable, it is 1, right? All of the combined different letters are all zeros, right? So this is 0, 0, 0. Where is it? 0, 0, 0. Okay, so these are all being multiplied by 1. So definitely they are just the same, right? So it will become negative 16, negative 12, plus 42, right? So what's negative 16 minus 12? It's negative 28 plus 42. So what's the value? Positive 14. Is that correct? Okay, 14 here.
Sir, can I ask, sir?
What?
Those that are cancelled, sir, it's already 0, sir?
Yes, because you're going to multiply them by 0.
Negative 16. Can you see again? We'll take a picture.
Okay.
Can I take a picture, please? I'm gonna take a picture. My phone's almost up.
Sir, why is 0?
Because there are combinations.
Wait, isn't it that we have here? Where is it? I told you to remember. Look.
Ah,
Oh, the dot product as well as the cross product of two vectors follow the distributive law. However, we need to evaluate the dot products as well as cross products of any two of the vectors. J, is equal to 1. J, K, are all zeros. Okay?
thank you, sir. Yes, sir.
Next is cross. Okay, this one. K is equal to 0. When it is X, there's a difference between a dot and X. Okay,
There was the difference.
these are the values. It is signed. But IJ and these are all zeros. But there is also a difference between the reversed form. IJ is K, but JI is negative K. JK is I, and KJ is negative I. KI is J, and now here on letter, what letter was that? Where was it? Letter C, the value is actually a real number when it is a dot product. Okay, the dot product is a real number answer. Okay, well, the X is not real. Okay, so let us see letter D. Actually, it's the same method when you multiply. Okay, D. Where is it? Is it reversed? What did we use on C? The dot, right? Now let us try E.
Yes, sir.
That was C. That was D, right? Yes. Next one is C.
Yes, sir. Letter D.
Since
Letter C
the
is
product gives a scalar
negative
quantity, then the
4.
answer must be purely a real number. Okay. Now let us try A times B. A times B. You will also do the same thing.
Distribute.
All right, what we have done on the C. But they have different values. Okay. Now all the double letters are 0. Unlike here, all the double letters are 1, right? Okay, on the
Yes, sir.
cross product, all the doubles are zeros. So let us see those with the doubles. Like this is 0. This one is 0 also. This one is also 0, right? Now, but the one that with I times J, they have a value with corresponding variable also. Like IJ corresponds to K. Okay. IK correspond. Open your ebooks on that page. What page was that? Here. Open your ebooks here. Page 47. This.
Page 47.
This one,
48. Okay, sir.
Okay. I'll ask one by one here. Look. What's the value of IJ? K, right? IJ.
20.
IJ first. IJ. K, right?
Yes,
IJ.
sir.
Yes, sir. K.
So K. So
K.
put K only. Instead of writing IJ, you will put K. All right? Now, what about IK? Negative J.
Negative J.
J.
Definitely you have to write the number 56. This is already 0, so no need to. Ji. It's reverse of ij, so negative k, right?
Yes.
Then this is 0, so don't, never mind. So what about jk?
It's
I.
It's I. All right, here.
Junko. It's Junko.
What about ki? It's the reverse of ik.
J.
Okay.
G.
What about kj?
I.
Negative
I or negative I?
Negative
Negative I.
Negative I.
Negative I.
But this is 0, right? So, right, negative 24k, negative 56j, because that's positive and negative, so put the negative there. Negative, negative is positive k, and here I, it's positive. And that's negative 12j plus 18i, right? So combine those with the same variables. Let's start with the I. 28 plus 28 will give you 46. J, negative 56 plus negative 12.
Negative 68.
Negative 68, J. And negative 24 plus 8 is negative 16. Okay, so the difference there is that here it's a real number, here it's with variables, okay? And the position should be I, J, K, right? So you have to refer on that because you will be doing the next exercise. What's the practice? Okay, let's go to letter F. F questions that there is letter F.
Sir, we solved it now. Oh wait, okay.
Do we have F?
The in vectors A and B. So next page.
F, the angle between vectors A and B. So we will be
Page
solving
49.
the vectors between A and B. Okay, let us try this. All right. So A times B is AB cosine theta, right? So as simple as that. The given are this. A is this, right? And the B is this.
Yes, sir.
So we took the first on how to get the magnitude, right? On the first discussion. This one and this one. So negative 8 squared, 4 squared, 6 squared, square root, you will get this. That's for A. And this 2, 3, 7, and then that's it. All right. So you get 7.87. Now to compute for the magnitudes of the vectors, it should be rounded off because they will be significantly effects. Okay, so we'll try to check this first, A and B, on your calculators.
Yes, sir. Sir, letter B is correct.
Okay, what about A? It is rounded off exactly 7.87.
Yes, sir. 7.87.
Whatever value you will get here, you have to put it, okay? Do not round off, even 5 decimal place, even this, okay? Right, now, what is the product, A dot B product? A dot B product, what did we get?
A dot B, 14.
This one, 14, right?
Yes,
So
sir.
you divide it to this, to the answer of the product of the two. So 40 cosine negative 1, 14 over 10.77 times 7.87. You will get here.
Sir, we won't round off, right?
Yeah.
Sir, it's very long then. It's 7.874007.
No, directly in the calculator. Divide this. Press shift cosine negative 1 and then this 2.
Sir, where did 14 came from again, sir?
The product, the dot product. AB, right? Here. Dot product 14 here. Right? This. Here 1.
Sir, we can't round off A and B.
Thank you,
No,
sir.
you can round up.
So
Press
how
this.
would it, how
Press
would
this in the
we,
calculator directly. Cosine negative 1 and 14 over 10.7 times that. You need to get 80.49.
yes, sir, I got 80.49.
Okay, or it can be 80.
49274765.
80 degrees, right? To be rounded.
Yes, sir.
Simple.
A little bit.
Why a little bit? Don't forget this formula, cosine negative 1. Dot product, since it's a real number. And then the vector A and B. Magnitudes, okay?
It's for the
Okay, so it's your time to do this.
homework, sir.
A, B, A plus B, A minus B, 0.5. It's the same process. One would have that. Okay? No need for you to stay longer here, so we can stop it. But you need to do this, all right? If you don't have any question, do you have, just ask question first. It's clear. Just only add A plus B, you add each, right? 3 plus 4, negative 4 minus 2. Same as with minus. When we the different thing in dot product and the cross product only. Okay?
Yes, sir.
Ask question before we will leave.
Sir, let's ask a question.
What? What's your
Sir,
question?
the rounding off, sir, like, sir, we rounded it off to the second decimal, sir. Is it okay?
Or
Okay.
do we
Okay, set the hundredths place here. 2 decimal places, it's okay. All right?
so for the final product of that equation, sir? Where do we round off, sir? Same place on the thousands?
Degrees can be.
Yeah, hundredths place. 2 decimal places.
2 decimal places.
Okay. Who else has a question?
If we'll make it to ano po, like 10, 10.8, then 7.9 po ganyan, will it still be 80 po?
No, there is a difference. 10.8 and 7 ways. You have to make
Have to
us 2
write that
decimal places, okay? All right. More question? Just a little bit long, so that's why you have to start it now. Okay? To get the angle, get the magnitude first, add square and then add and then square root. And then we'll get the dot product. Make sure that your dot product is correct, okay? Because you're going to get different answer. All right? You have to start writing your formulas because on the exam, yeah, you will be needing that. Rather than you will check first your notes. It's better that you have the summary. Okay? Summary again. Yes, Amir. compare all your. It's better that one student would just prepare, or 2 or 3. Like Amir, Julian, Jenny, Rowan. Prepare all the formulas, and then you have to brainstorm, and you will check if your formulas are exactly the same, and you can show it to your other classmates, rather than your classmates will be doing, and some were not actually complete. Okay. Do you agree on that, Julian? Amir, Rawan, Jenny?
Yes po, sir.
Yes, sir.
What about the others? Definitely, right?
Sure.
Okay, so that will be all for today, and you have to do your work.
Sir, question.
Yes, question.
Sir, why is there like an arrow on top of the letters?
That's just a representation. That is called hut. It's like a meme, right? That's representative of a vector. There's an arrow. Okay. What else, Julian?
So what does it mean,
Don't
sir?
want me to leave. It's a vector.
Ah, okay. Means vector. Okay.
Adrian, you're so quiet there. You're eating orange already?
Sir, not yet.
Kayla, any question?
None, sir.
Okay. So silence means yes, right, Hisham? Okay, then that's all for today. Let's call it a day. Anytime I rest from the morning, I was teaching. I don't have voice anymore. No break.
Bye, sir. Rest well.
Prioritize your health.
Hi, sir.
Rest well, sir.
Bye,
Po.
sir.
Bye-bye.
Bye, sir.
Thank you,
Thank
sir.
you.
Bless,
Sir,
sir.
thank you.
Nice.
Bye.
AMR.
How to end this?
Ter.
I'm confused anymore because
Ter.
in my school I'm using different, what do you call this?
Ter.
Google Meet, sir.
No, it's Classera. So when you were in grade 8, you were expanding a binomial already, or a polynomial. So for example, you have to expand x plus y squared. So you know that when you expand this, it can be x plus y and x plus y. And then after that, you are going to distribute x times x will be x squared. X times y will be x, y positive. And this is also positive, x, y. And this is y squared. Do you remember this? It will become x squared plus 2xy. Even last year, right? So we have a binomial. What about when we have x plus y cubed? Right? So we will multiply this again by x plus y. What about when we have x plus y to the 4th? X plus y to the 5th? And so on until x plus y to the 9th, to the nth power. Okay? So in this lesson, we are going to use the Pascal's triangle to find the pattern on how to expand a binomial. Okay? So I will show you this Pascal's triangle. This starts with 1 and then 1 here. So this is a triangle. Now, if you put 1 here, all right, you add this 1 plus 1 will be 2. And this is 1. You add this. 1 plus 1 will be this 2. Okay, all of the numbers here are 1. The perimeter of the triangle is all 1. So here, 1. Then 1 plus 2 will be 3. 2 plus 1 will be 3. And then there is another 1 here. And then let's go again here, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And then this is 1 again. All right. So let's complete. This is another 1. Then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And this is another 1. Okay, so let us continue again. It is 1. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. And then 1. Okay. And then 1 again. 1 plus 6, 7. 6 plus 15, 21. 15 plus 20 is 35. And then this is 35 also. 21, 7, and 1. And so on. That is the process. Okay? That is the process. This is called Pascal's triangle. You add the numbers in the middle. Okay? Now, what is this all about? Okay? These are what we call the numerical coefficient of each term in every binomial that you need to expand. Okay? So, this will start with x plus 1, x plus y raised to 0. This is x plus y raised to 1, x plus y raised to 2, x plus y raised to 3, x plus y raised to 4, x plus y raised to 5, x plus y raised to 6, x plus y raised to 7, and so on, x plus y raised to n. Okay, the nth term. So what is this all about? So as you can see that this is the number when we have example x plus y squared, you will get the answer x squared plus 2xy plus y squared, right? This one. Okay, when we did that, look at the numerical coefficients of this. This one is 1, which is 1. This one is 2, and this is 2. This one is 1, and this is 1. All right? So when you expand the x plus y to the power of 3, you are expecting that the coefficient, numerical coefficient of each power 1, 3, 3, 1. So let us try how to do that without multiplication. So look at the highest power of expanding. Look at the power of 3. You will start with 3, all right? So x cubed. After that, x squared. After x squared is x, all right? And since you're done with the x, you will start with y cubed. Okay? Now, after the x cubed here, you will start with the y. This is y to the power of 1, y to the power of 2, and then 3. 1, 2, 3. All right? So after that, you have to write the numerical coefficients. What's the numerical coefficients? What are the numerical coefficients here? Here is 1. We are not writing the 1. Next is 3. We'll put 3 here. Next, another 3 here. Next is 1. So therefore, our final answer would be this. Expand this, x plus y cubed, you will get an answer. X cubed plus 3x squared y plus 3xy squared plus y cubed. All right? So let's go to y to the fourth. Look at the y to the fourth. All right? DJ, what are you looking at? All right. Y to the fourth. We will start to the highest power, which is what? Which is y to the fourth. We'll start to the fourth. So x to the fourth. Then x cubed, x squared, x, and y to the fourth. When you're done with the x, it starts with y to the fourth. And then after that, you will start with y here. All right? So y to the first power, y to the second power, and y cubed. Okay? So what are the numerical coefficients, Daniel? Will you say the numerical coefficients? Tell me.
1, 4, 6,
1, 4, 6, 4, and
1.
1. Okay. So that's how to expand y to the fourth. Okay? Now, since all are positive, we will do it. Plus, 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 plus. Okay? So x to the fourth plus 4x cubed y plus 6x squared y, y squared plus 4xy cubed plus y to the fourth. Now let's go to the fifth. Okay, to the fifth. Shane, will you tell me what would be the highest variable?
X to the fifth power po.
Then x to the fourth, x cubed, x squared, x and y to the fifth. All right, then we'll write the y now. Y squared, y cubed, and y to the fourth. All right? Jonathan, will you tell me the numerical coefficients? We'll start with 1. Next.
5,
5,
10,
10,
10,
10,
5,
and 1.
1.
So all are plus. Instead of writing all and multiplying, it's easier, right? Now, on our example is x plus y to the 7th. Okay, let's answer our x plus y to the 7th. So remember all of this. Just tell me after 1, 7, 21, 35, 35, 21, 7, and 1, which is our question. Use the in Pascal's triangle to write x plus y plus 7 in expanded form, right? 1, 7, 21, 35. 1, 7, 21, 35, okay? So let us see to expand this. Okay. Michelle, will you tell me the highest power?
X raised to 7 po.
Okay, x raised to 7. Then 6, 5, 4, 3, 2, 1. And the last would be y to the power of 7. Next, let's go to the y. Start from here. Y squared, y cubed, y to the fourth, y to the fifth, y to the sixth, and then 7. Now, let's go to the variables. We have 1 plus 7 plus 21 plus 35 plus 35 plus 21 plus 7 plus 1. So that's it. 7, 21, 35, 35, 21, 7, 1. Okay? Did you get it? It's easy. Now, in the entrance exam, they will ask the question like this. Okay. In entrance exam, usually, last time it went out like, in x plus y raised to 7, what is the numerical coefficient of the x cubed y to the fourth? Okay, x cubed y to the fourth term. So what would be your answer? Your answer should be 35. Okay, that's how you will do it. So if you know the Pascal's triangle, then you can be able to answer. And later, how do we solve that without using the Pascal's triangle? Okay, so there is a rule to do that. Okay. Okay, now will you tell me and answer now x plus y to the power of 8? Will you expand this? I will be waiting for your answers. Expand that first. Let us answer now. We have this. So we are going to use the formula. Let us try the formula that's given on our book. So it should be the value of n minus 1. So to get the value, n minus 1. Okay, so let us try this. This is X plus y to the power of 8. Let's start first here. So this is 1, 8, 28. 21 plus 35 will give you 56. Then 70, 56. Then 28. Then 1. 8 and 1. You got this all? 1, 8, 28, 56, 70, 56, 28, 8, and 1. Right? Okay, so if you got those, now let us go to this formula. So let us try this formula. If n is positive integer, then the value of the start would be 1x raised to n, y raised to 0 plus n times x n minus 1 times y plus n open bracket n minus 1 x n minus 2 y squared plus and so on. So let us try to answer number 2 example, letter A. So let us start with the first one. So we have 1 x raised to n. What's the value of n? Is 4. So n is 4. Okay. Then you will start with y raised to 0 because that is given. Plus n. What is the n? It's 4 times x raised to n 4 minus 1 times y plus n. This is our formula we are following, okay? N is 4 times 4 minus 1 all over 1 times 2. Okay, next. X raised to n minus 2. So 4 minus 2. And then y squared. Plus, let us follow the formula. We have this formula n minus 1. So we have on the third power 4 minus 1 all over 1 times 2 times 3. So plus our x raised to 4 minus 3. Then it will become y to the power of 3 until it will end on the last part, which we have until to the 4 plus 4. So that's the end already of the last part. So we don't have any more on that 4. Since that's the last digit is 4, so plus 1 x raised to 0 y to the power of 4. Because we end up on the y3. Okay? So therefore, let's find the answer. So this is already 1 and this is 1. So it will be x to the 4th. This will be plus 4x cubed y plus 4 times 3 is 12. 12 divided by 2 is 6. 6x squared y squared plus 4 times 3 is 12 divided by 6 is, we have 1 and 2. 4 times 3 is 12. 12 divided by 6, it should be that it doesn't have 3. It should be 2 only. So plus 4. Wait. 4 times 3 is 12, right? 12 divided by 2. Should be 4, right? That should be 3. Let us see again the formula. Four times 3. Where are we now? Okay. So we are on the second. The first is this. 4, 1, 3. 4 times 3. 4 times 3 is 12. Divided by 2 is 6. And then this should be 4. 4 times 4 times 1 divided by, this should be 3. So that will become 4. 4x squared cubed. What this should be 1. And then the other one, this should be 1x. And lastly, we have x is 0, so that should be 1. Y to the 4th. Look at the Pascal's triangles. If we have 4, 4, 6, 4, 1. Right? 4, 6, 4, 1. Because on the power of 3, it's the y. Then the other one is 4. Okay? Or we can also use that formula that we used here. Here. What's that? 1, 4, 6, 4, 1. Okay, correct. Right? 1, 4, 6, 1, 4. Now we answer 6 and 7 also, right? We expanded this already, correct? Okay. Now which is easier for you, just do it, okay? All right, let's go
Is there an easier way from both of them? Easier than both?
You're asking about easier than those two?
Yes, po. A shorter version.
Okay, so let us see. This is what we call this one. That is easier, okay? The binomial expansion. And it's much more complicated to see, right?
It looks so complicated. Just look at it.
Let us see that. But we have to study first what do you mean by factorial. If n is a positive integer, n factorial read as n factorial is defined by to be the product of all positive integers from 1 through n. So n factorial, which evaluate, you have your calculator. You will see that on above the part of the calculator, it is above x raised to -1. There is what we call factorial like this. All right. So you have to press your shift. Press shift. And then this button, it is on the upper right of your calculator. Then you will see exclamation point. That is called factorial. So just press that. A 9 factorial over 5 factorial. 9 factorial over 9 factorial divided by 5 factorial. What's the answer?
3024.
Okay, 3024. In a long way on how to do that, it's like this. 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial 5 times 4 times 3 times 2 times 1. And then you can actually cancel this because it's division and it's a product. Then you will multiply this and that would be 3024. So try it. What's the answer? 3024? 9 times 8 times 7 times 6. What is the answer? 3024, right?
Yes, sir.
Okay. Now, what about letter B? What's the answer? Enter in your calculator. Some you will get math error. Who got math error?
2,520 po.
Who got math error? Yes, the correct answer is 2,520. You'll get math error here because you need to write multiplication sign. Okay? So here, you can say 9 factorial will be 9 times 8 times 7 times 6 times 5 times 4 factorial. Stop it there because there is 4 factorial and 3 factorial. So this is already canceled. And this 3 factorial is 6, so cancel the 6. So multiply 9, 8, 7, and 5. So 9 times 8 times 7 times 5 is 2,520. Same as with letter C. So letter C, the answer is 10 factorial. 10 shift factorial over 7 factorial times 3 factorial. It's 120. Okay, so this can be written as 10 times 9 times 8 times 7. So 7, stop it there because there is 7 there. And 3 factorial. So cancel the 7. So this is 6. So 10 times 9 times 8. It's 720 divided by 6. And that is 120. Okay? So that's easy. Now let's go to the next one, which is binomial theorem. Okay, what does it mean by this binomial theorem? Okay, anyway, we will postpone this. This is easy only. You will realize that later. It's easier because you are going to use factorial by this time. Okay, now I will give you work on how to expand number . Okay. Numbers 1 and 2 only here. 1 and 2. On your book, okay? Numbers 1 and 2 on your book. Okay? And tomorrow we are going